Right now, you are breathing. You didn't think about it. You didn't plan it. Your lungs expanded, pulled in 21% oxygen, filtered out CO2, and kept you alive automatically, for free. A child running barefoot on grass. A woman swimming in the ocean. Friends dancing at a rooftop party. You swim in oceans held by perfectly tuned gravity. You run under a sun sitting exactly 150 million kilometers away, close enough to warm you, far enough not to kill you. Scientists call this the Goldilocks zone. Earth is not just a planet. Earth is a miracle engineered over 4.5 billion years. So what happens when we leave it? Born Without a Planet, Episode 1, The Survival Problem. Number Chapter 1, What Earth Gives You That Space Doesn't. Let's start with the brutal truth. Space wants to kill you, and it is extraordinarily good at it. Step outside without a spacesuit on Mars. Here's what happens in 60 seconds. Your blood begins to boil not from heat, but from pressure collapse. Mars has less than 1% of Earth's atmospheric pressure. At 0.6%, your bodily fluids vaporize. The temperature swings from plus 20 degrees Celsius on a summer afternoon to -solvent 125 degrees Celsius at the poles at night. You'd freeze solid before your body could react. The air is 95.3% carbon dioxide. One breath unconscious, two dead. And then there's the invisible killer. Cosmic radiation, raining down at 0.67 millisieverts per day. 40 times more than a chest x-ray every single day. NASA confirms a 6-month Mars mission exposes astronauts to 300 millisieverts, nearly the lifetime recommended limit for radiation workers. Earth's atmosphere, magnetic field, and ozone layer form a triple-layered shield built over billions of years. It blocks 99.9% of ultraviolet radiation, deflects solar wind that would strip our air away, and holds pressure stable enough for liquid water to exist. Lose that shield? Welcome to the rest of the universe. Chapter 2. Living in a 5-kilometer machine. So if planets are hostile, what if we build our own world instead? In 1975, Princeton physicist Gerard K. O'Neill proposed exactly that. He called them O'Neill cylinders, two massive tubes, each 8 kilometers long and 3.2 kilometers in diameter, rotating in opposite directions to cancel gyroscopic forces. Inside, rotation creates artificial gravity exactly 1 g, the same pull as Earth. Interior surface area of one cylinder, 80 square kilometers, roughly the size of Manhattan. Rivers, forests, cities, all spinning quietly in the void. NASA's 1975 Space Settlement Study scaled this up further, the Stanford Torus, a ring-shaped habitat 1.8 kilometers in diameter, designed to house 10,000 people. The engineering math is real. The physics works. What we've lacked is cost. But costs are collapsing. SpaceX's Starship is projected to reach $100 per kilogram to orbit a 99.8% cost reduction from the space shuttle era. When that threshold breaks, building in space stops being fantasy and starts being engineering. The air problem. The ISS has been solving the air problem since 2000 using ECLSS, the Environmental Control and Life Support System. It electrolyzes water, splitting H2O into hydrogen and oxygen. Astronauts breathe the oxygen. The hydrogen recombines with exhaled CO2 to produce water, again a closed loop. Current ECLSS recycles 90% of water aboard the ISS. A 2023 NASA upgrade is pushing oxygen recovery toward 98%. For a space city of 100,000 people, closed-loop life support isn't a luxury. It is the difference between life and death. The water problem. Here's something most people don't know. The asteroid belt between Mars and Jupiter contains an estimated 1 quintillion kilograms of water ice. That's a 1 followed by 18 zeros. The dwarf planet Ceres alone may contain more fresh water than all of Earth's oceans combined. A 2019 study in Nature Astronomy confirmed a deep brine layer beneath its surface, potentially hundreds of kilometers thick. Space is not dry, we just need to learn how to drink it. Farming the void. Every space colonist needs approximately 2,000 calories per day, and shipping food from Earth is economically insane, so you grow it. NASA's Veggie Project has been successfully growing lettuce, radishes, and mustard greens aboard the ISS since 2014. Research from the University of Arizona's Controlled Environment Agriculture Center shows vertical hydroponic farming yields 75 times more food per square foot than conventional soil farming. using 95% less water. For a habitat population of 10,000, models suggest 1,400 hectares of vertical growing area, achievable inside a large enough cylinder, using multi-tiered systems. And here's the beautiful part. Plants don't just feed you. They absorb CO2 and release oxygen. In a sealed habitat, crops aren't just food, they're atmosphere, their infrastructure, their life itself. Chapter 3. Calling home communication across the void. Now for the part nobody talks about. Not the engineering, the loneliness. When Mars is at its closest point to Earth, 54.6 million kilometers, a message traveling at the speed of light takes 3 minutes to arrive. A reply takes 3 minutes to come back. 6 minutes round trip. Manageable. But at Mars' farthest point, 401 million kilometers, that same message takes 22 minutes one way, 44 minutes round trip. No live phone calls. No, are you okay in real time. No shared moment. You don't talk to your family. You compose messages to them, and then you wait. Like letters sent across an ocean, except the ocean is 100 million kilometers of vacuum. The physics of special relativity forbids faster than light communication. There is no workaround. No hack, no cheat code. NASA's Deep Space Network, 3 massive antenna complexes on 3 continents, currently transmits data at up to 100 megabits per second to spacecraft in the inner solar system. By 2030, NASA's optical laser communication systems are projected to reach 1 gigabit per second, fast enough to stream 4K video from Mars orbit. The bandwidth problem is being solved, but the delay cannot be. That's why engineers at NASA developed the delay-tolerant networking (DTN) protocol, tested aboard the ISS since 2008. Think of it as the internet redesigned for a solar system. Data packets are stored, rerouted around planetary blackouts, and automatically forwarded when a path opens. It doesn't eliminate the wait, but it makes the wait work. The first people to leave for Mars will compose video diaries, not make calls. They will know their children's first words hours after they were spoken. They will grieve at funerals they cannot attend. This is not a technology problem. This is a human problem, and no satellite can fix it. We've seen the problems. A universe built to kill us. The machines we'd need to survive it. The crops that would feed us. The water hiding in asteroids. And the silence of space that no technology can break. But this is only half the story. In episode 2, we go further. We ask what happens to the human body over years in space. What gravity does to your bones. What radiation does to your DNA. And what millions of years of evolution will do to the descendants of space colonists. We'll explore terraforming Mars, turning a dead planet into a breathing world. We'll ask if there are already Earth-like planets waiting for us in the dark. And we'll confront the most uncomfortable question of all. Will the humans who reach the stars still be human? If this changed how you see the sky, share it. Leave a comment. Tell me, would you leave Earth forever? Stay curious. Stay human. Part 2 is coming.